Hi and welcome to this video where we're going to go through how to do some pH calculations for strong acids and bases. Now this is really just a recap of level 2 calculations, but it's useful to start with. Okay, so the first thing to remember when we're thinking about this is actually what is pH? Well, pH is just another way of writing the hydronium or hydrogen ion concentration. Okay, so it's the negative log of the hydronium ion concentration. Now, the other thing to be aware of, always, is that the hydronium ion concentration and the hydroxide ion concentration are linked by Kw. Okay, so as hydronium ion goes up, hydroxide goes down, or vice versa. And because pH is a negative log, its pattern works in the opposite way to what you might expect with the hydronium ion concentration. So as the hydronium ion concentration increases, pH decreases and vice versa. So the smaller your pH, the higher your hydronium ion concentration becomes. Okay, so if you've got a pH of 13, then that is a really, really tiny hydronium concentration. If you've got a pH of 1, that is a really big hydronium ion concentration. Relative, right? So pH, remember, is just another way of writing the hydronium ion concentration. And pH, H3O plus and OH minus are integrally linked. Okay? Because the Kw is the concentration of hydronium times the concentration of hydroxide, and it is a constant. Okay? So we can calculate pH as negative log of hydronium concentration, and we can calculate H3O plus as 10 to the negative pH. So this is just the inverse or shift log function on your calculator. Now there is another formula, which I haven't included in here, but I do actually use a lot, which is POH, which is exactly the same thing for the hydroxide ion concentration. The reason I use POH a lot is it, to me, is easier when I'm working on pHs of bases or hydronium ion, hydroxide ion concentrations, things like that. Okay, so remembering Kw is the concentration of hydronium times the concentration of hydroxide, and it is a constant. It is equal to 1 times 10 to the minus 14 at 25 degrees C and 1 atmosphere of pressure. And so you can rearrange that equation to convert between hydronium and hydroxide ion concentrations at any point in time. On your formula sheet you get given the formula for pH, and I believe you get given the formula for Kw as well. Now I put them together in this kind of a diagram, which you may have seen earlier, which I do something very, very similar with Ka and Kb. So converting from hydronium to pH, you've got your negative log of your hydronium. Going back the other way, hydronium is 10 to the negative pH. From pH to POH, you've just got 14 minus the opposite one. From hydronium to hydroxide, you've got that Kw expression rearranged, and then from hydroxide to POH, you've got the same formulas that you have above for pH. Now these become really useful further down the track, and you don't have to memorize this diagram. Some people hate this diagram. I love it, but for me it makes sense for getting from one thing to the next. Other people, not so much sense. So if it works for you, stick with it. If it doesn't work with you, just ignore it. Okay. So just a reminder, if you have a large Ka or a small pKa, then you have a strong acid, or similarly for a base, which means it completely dissociates from water. So you can assume that the hydronium ion concentration is directly related to the concentration of your strong acid. Okay, because if your strong acid is completely dissociating, then all of that acid is turning into H3O plus, which means you can work out the concentration of H3O plus directly. And then once you've got your H3O plus concentration, it's very easy to convert to pH. you can do the same thing for a base. And so you can calculate your OH minus concentration directly from the concentration of your base, and then from that you can then get your H3O plus and pH, or your POH and then pH. So I'm going to show you a couple of examples of these calculations, because I think the worked examples make far more sense quite often than words. So the first one is a very straightforward example that anybody who passed level 2 chemistry should be able to do, and that is to calculate the pH of a 0.15 mole per litre solution of HCl. Now this, I start always with an equation. So in this case, HCl plus water makes hydronium and chloride, and because it's a strong acid, and HCl is on that list of strong acids, so you should be able to recognise them. Because HCl is a strong acid, we can assume that if the concentration of HCl was 0.15 mole per litre, that it's going to completely dissociate, and therefore the concentration of hydronium is going to be 0.15 mole per litre. Now we know pH is negative log of the hydronium ion concentration, so at that point it's simply a matter of putting the numbers into the formula into your calculator and determining that the pH is 0.824. pH has no units. Right. So that is very simple, calculating pH from the concentration of a strong acid. You can of course go the opposite way, and I'm actually going to do that with a base. So in this case, what is the concentration of a solution of sodium hydroxide that has a pH of 13.1? So the first thing, again, always start with the formula, because the formula sets everything clear in your head with the equation. So if we know that the pH is 13.1, now we've got we want to find out the concentration of sodium hydroxide, which means we need to know the hydroxide ion concentration. So for me, the easiest way, once I've started with the pH, is to actually calculate POH as 14 minus pH, which is 13.1, so I know that my POH is 0.9. From there, I can then convert from POH to the concentration of OH minus. 10 to the negative POH, so just sticking that straight into my calculator, and I've got a concentration of hydroxide ions of 0.126 mole per litre. Now, because of this formula, we know that the concentration of sodium hydroxide must have been 0.126 mole per litre. Now this is a very, very quick recap. If this seems very confusing to you, please go back and look at some of the level 2 content first. Make sure you're on top of that and then come back to this. Okay, there is no point in trying to figure out how to calculate the pH of a weak acid or a weak base, which is where I'm going to next, if you can't yet do a strong acid or a strong base. Okay. Otherwise, I will see you in my next video, which is going to be looking at the pH of a weak acid or a weak base. See you there.